Hey everyone, so let's take a look at this question which comes from a quiz from Calculus 3, but it's really very simple if you just understand what's going on. So the question states, find the plane that passes through this point and that is perpendicular to both of these planes. Okay? So what we need to do to find the equation of a plane, we need a point, which is given to us here, and we need a normal vector. A normal vector, meaning a vector which is perpendicular to the plane. Well, if we take the cross product of just the coefficients of these two equations, what we get a vector which is perpendicular to both of these. And then also to the plane we want. So all we have to do is take the cross product, take this normal vector, you can call it n vector, just equals the cross product of the coefficients here. So just 2, 1, negative 2. And then we cross that with the coefficients of this equation. Well, we have 1x, we have no y's, and we have 3 z's. So we have 1 and then 0, because there's 0 y's, and then 3. Okay? And then to do our cross product, well, we just always write your I, J, K, and then write this vector right beneath it. So 2, 1, negative 2, and then 1, 0, 3. Okay? And what does this equal? Well, it just equals I times its minor, which is just, if you cross out your I column and row, just left with 1 minus 2, 0, 3. So 1 minus 2, 0, 3. And that's always going to be minus j times its minor. So if you cross out the column and row of j, you're left with 2 minus 2, 1, 3. So 2 minus 2 minus 2, 1, 3. And then plus k times its minor. Well, if you cross out the row and column of k, you're left with 2, 1, 1, 0. So 2, 1, 1, 0. Okay, and then that equals what? Well, to do the determinant here, you're just left with 3 times 1 minus the product of this diagonal. So that's 3 minus, well, 0 times minus 2 is 0. So that's 3 minus 0, which is 3. So it's 3 times I. So 3I. And then minus, well, 3 times 2, 6. But then it's 6 minus a minus 2. Right? Because here you got 6. It's always minus the product of this diagonal. So it's 6 minus a minus 2, or 6 plus 2, which is 8. But then it's minus j. So it's minus 8 j. And then plus how many k? Well, it's 2 times 0, 0 minus 1 times 1. So 0 minus 1, minus 1. So it's plus a minus 1, or minus 1k, or just minus k. Okay, so here, and then our vector, right, the vector we need, we call it vector, we call it ABC, just equals the coefficients on our I, J, and K. So 3 minus 8 and minus 1. So 3 minus 8 minus 1. And then that's all we need. And then the equation of a plane is just given by, if we have our vector here, ABC, and we have a point that was given to us originally. Our point was 1, 5, 1. So we have our vector, and our point was already given to us as 1, 5, 1. Okay, there's our point. Then the equation of a plane is just A, right? Our component here, A times x minus x naught. And x naught is just our point. It's our x coordinate. If we're given an x, y, z coordinate, our x naught is just our x coordinate. So it's x minus x naught. X minus our x. And then plus b times y minus y naught. And then plus c times z minus z naught. And that's, I mean, I remember this as just, it's your a, b, c. And it's times x, y, z, right? A times x minus x naught plus b times y minus y naught plus c times z minus z naught. Well, all we had to do was take our cross product to get our vector. We already had our point, so we just plug into this equation right here and get what? Well, a is 3. So we have 3 times x minus our x naught. Well, our x is 1. So it's 3 times x minus 1. And then it's plus, what is our b? Our b is minus 8. Well, so it's actually minus, right? So it's plus b, but b is a minus 8. So it's plus a minus 8, or minus 8 times y minus y naught. And our y was 5. And then plus c. Well, c is a minus 1. So it's minus 1, which you have to write, just minus. So minus 1 times z minus z naught. And z was a 1, so z minus 1. And there you go. And this, I should have said, this equation we originally had, a times x minus x naught plus b times y minus y naught plus c times z minus z naught. Well, that is equal to 0. That's the equation, the standard equation of a plane. If you can see the whole thing, there it is. So this is equal to 0. And then, I mean, that's the equation of a plane, but we can definitely clean it up by just distributing here to get 3x minus 3 minus 8y plus 40, right? Minus 8 times minus 5 plus 40 minus z, and then minus a minus 1 plus 1 equals 0. So we have minus 3 plus 1, and then a plus 40. So it's minus 3 plus 1 is minus 2 plus 40. So that's 40 minus 2, which is 38. But then we can move the 38 to this side to get minus 38. So we're just left with 3x minus 8y minus z, right? That's we have a 3x, a minus 8y, and a minus z. And then if we add our constants, the minus 3 plus 40 plus 1, we get 38. But then we can subtract the 38, move it over to get equals minus 38. And there we go. There's the equation of the plane that passes through, again, the point that we were given, and it's perpendicular to both of these planes. And how do we do it? We just took the coefficients on our two planes, took the cross product, pretty simple, and then we had our equation of a plane, and we just took our vector. Again, we needed a point and we needed a normal vector, or a vector which was perpendicular to the plane. And if we found a vector perpendicular to both the planes, it would be also perpendicular to the plane we wanted. And then we just plug that right into our formula, and there we go. Pretty simple. All right, see you guys later.